Okay, today the question is about principle of mathematical induction. This is an usual question which will be asked in combined mathematics under partA, not only under partA, but we will discuss about this question only today. So usually will be given as the first question in this part, right? So directly it's better to pay attention on this question. Using the principle of mathematical induction, prove that summation r equals from 1 to n. This is the general term. Then this is going to be equal to right hand side, where for all n is an element of positive integers, right? So let's see how we can do it. First of all, let's write down this summation r is from 1 to n, right? You remember that it can be derived, right? And n plus 1 plus n times n plus 1 times n plus 2 over 3, right? Okay, first of all we have to show that this is working on the first term, right? N equals 1. Actually this is started with n equals 1 because for all n is an element of positive integers, right? So it will be started with n equals 1, so that's why I'm going to substitute here n equals 1. Sometimes it's up to the series, right? It's up to the series of the statement what you are given mathematically, right? So you have to understand the particular scenario. So in this particular scenario, this is started with n equals 1, right? So therefore you can substitute over left hand side. When n equals 1, what does it say? Normally students do not like to write this down likewise, but this is the proper way we had maintained, right? So what does this say? From first term to the first term, it means that it remains with first term only, right? So this is a general term. If you are looking for the first term, this is the r term, right? If you are looking for the first term, what we have to do is r is replaced with 1, right? So 1 times 1 plus 1, it's just 2, right? So when you substitute it over here over left hand side, it's going to be equal to 2, right? At rest, then what you have to do is you have to work on the right hand side also, right? RHS once n equals 1, right? Under this one I don't have enough space to interpret it, so I have split it. So then what we can do, I'll erase this one right now. Then RHS was 1 times 1 plus 1 times 1 plus 2 over 3. You can see that it's gonna be equal to 2. It's nothing else, just left hand side. So we can say simply when n equals 1, it's true, right? You have to state that. So also the students, that's the common thing I have seen, that they do not used to write it down, right? So what's the next thing we have to do? Actually the concept behind this mathematical induction is based on very logical conceptual theorems. Now we have to understand that, but this is not time to explain everything, because my focus is to just explain the question only, right? So in next session I hope to talk about mathematical induction fully, right? Actually, that's a very interesting one, but most of the students, I feel like they do not understand that, but they used to just follow up the strategy, right? When they are working on every questions, they are using just the strategies and they are following up them, and they do not actually they are blind on these theorems, but they do not understand. They have not proper image of these theorems, right? Okay, so now the hypothesis, actually this is the assumption, right? Let n equals p, and we have to mention that p is an element of positive integer, right? So likewise, so then it is true, we assume that, right? We assume that it is true, right? So according to this it's working on up to this is a series, right? It's working up to the pth term, right? It's working up to the p term. So then this is p plus 2 third, right? So we assume that this is true. We assume that this is true. Let it be equation 1, right? This is the assumption. So most of the students, I have seen that they do not use to interpret this one, right? They do not use to say, well, p is an element of positive integer, right? So this is very compulsory. Otherwise, in combined mathematics, you will lose your marks for this particular statement, right? Not only n equals p, let n equals p, and not only stating just that's an assumption, but also you have to introduce what about little p you have kept, right? Sometimes we are not able to use little p because little p is used already in your statement, in your mathematical statement. So once it is used almost, you are not allowed to use it again for any other particular purpose, right? So at that moment you have to be wise enough to switch that element, right? So everything must be done with understanding, not only with reciting, right? Okay, then I'm gonna go forward. What we have to do is n equals p plus 1. We have to show that this is comment, right? I know that most of you guys you don't know programming, right? But in programming also we used to put comments because of understanding, or because of having better understand, right? Once n equals p plus 1, we have to show that, right? We have to show that it is given as an instruction for us, right? It is given ourselves. So for us, this is statement for us, right? So it must be written like this: n equals p plus. You have to show that, right? Have to show that it's working on n equals p plus 1 also, right? It's just a comment, right? Okay, so how it will be look like, r is from 1 to p plus 1. There are so many ways to interpret the same, right? I'm gonna start it with left hand side. Even you can interpret the same using some more interpretation methods we have, right? This is one of successive interpretation method I'm going to use, right? So I'll go for another slide, right? Okay, then we have split by here. Then I'm gonna split this into two parts. Sorry, I'm gonna split this into two parts, right? How I can split it? There are so many ways. There are various types of ways. There are numerous ways. As you can say, from first term to 100th term. After that, it is started from 101 and up to p plus first term, right? So there are so many ways, but what is the most useful way among them, right? It must be meaningful, right? Otherwise, though we have so many interpretation methods, if they are not working on this computation, this showing, right? This proof, no need to use them, right? Okay, so what is that from first term to p term? Because it is in our assumption. So after that, actually you have to introduce this in advance, right? Otherwise you cannot use that. Even you can use it as you are. This was you are. What was you are? R times r plus 1. This was the universal term or common term, right? We can say like that. So then according to that, if this is a chain, right? If this is a chain, there are links. So terms are interpreted by links. So then first link for the first term, second link is for the stands for the second term, like that. This is up to p term, right? So it is given by this one. Not only that, because it is started from first term up to and continued up to p plus first term, right? So we have to add it, right? Actually, this is a very simple thing. I think you can understand it easily, right? No need to draw them, right? Okay, then this is introduced in your assumption from 1, right? So you can directly use that now. You're allowed to use that now because you have mentioned it in your assumption, right? It's better to write equation number 1 and put a semicolon there. And what about this p plus first term? If p term is r times r plus 1, instead of r you can substitute there. Instead of r you can substitute p plus 1, right? So then p plus 1 times p plus 1 plus 1. Actually this is the p plus first term, right? Okay, you can see that. Then what you have to show? You have to show that instead of p, instead of n, right? Actually instead of n, everywhere there must be p plus 1. Then you can say, I'll explain that behind the theory. That's very complicated, and you have to understand that probably. But I'll explain that concept later, right? For now, I'll show you how to do that. Then you can understand that instead of n, if you can make appear p plus 1, you have gone for the purpose, right? What you have to achieve. Then you can say it's working on p plus first term also. Then hence mathematical induction. You can say it is working on everyone. Everyone means when n can take any positive integer, right? It's working on positive integers only according to the mathematical induction. So what we can do, some students, they used to simplify this. They used to expand this. No need to expand. What we have to do, we have to factorize. We have to factorize. If you are trying to do the expansion, it means that you're gonna mess it up, right? Because it is jammed up and you wanna factorize it again, right? So in this case, you can identify these factors. These are factors, right? P plus 1 is a factor, and again p plus 2. Not only p plus 1 but also p plus 2. So what is the remaining factor here? P over 3, then plus 1. I used to get the common denominator at once, so I can write this down. I do not have enough space to write this down instead after this one. So it must be written after this, right? P plus 1. Instead of p plus 2, I used to interpret it like this: p plus 1 plus 1, right? And again p plus 3 is p plus 1 plus 2, right? Then you can see instead of n, everywhere you can see p plus 1 is there, right? P plus 1 is over there, right? Then you can say you have to write it down, right? I used to write it down like this, right? I used to write it down like this. Okay, so what I have written there, according to mathematical induction, we have to betray mathematical induction because we have totally depended on mathematical induction, right? Okay, so then we have betrayed mathematical induction. According to mathematical induction, for all positive integers, for all when n can take any positive integer, this mathematical expression is true, right? So you have to say that, right? You have to illustrate it at rest. Then you can get total marks, right? Okay, thank you.